Um, so we went over comets and how the outgassing of vapors creates the tail, and the tail is always moving away from the sun, whether the comet is or not. So sometimes it's kind of pointed in the right direction, the way our brains work, because tails should come out the back. But sometimes it's coming out the front, and the tail is actually pointing in the direction that the comet is headed. Just depends on the comet and where it's at. Then we get into meteors. And so we didn't cover meteors in yesterday's video or lecture. There are three different names for meteors, depending on what location they're in. So you have meteors, you have meteoroids, and then you have meteorites. And they go in this order. Meteoroids are when they're up in space. Before they come to the Earth, they're meteoroids. So if they stay in space, they're always considered a meteoroid. When they come down through the atmosphere and they become a shooting star, they're starting to burn up, that's when they become a meteor. And then if they hit the ground, if they survive the atmosphere and actually land on the surface and you can go and pick it up, then it's called a meteorite. So the rocks here on Earth that came from meteors are called meteorites. If they never come here to Earth and they're in space, they're called meteors. Just a little side note, the difference between an asteroid and a meteor or a meteoroid is just a size difference. In general, I don't think they have it listed here, but meteoroids are probably like maybe 2.5 meters or less, where asteroids are going to be bigger, hundreds of meters, maybe miles wide. So asteroids are big ones, meteors are small ones. They have 4 different types. You have iron ones, which are pretty common. You can find a lot of these, and there might be a TV show about meteor hunters that go out with like metal detectors, and you can find the nice iron ones. They have rocky ones that are similar to the rocks that you find here on Earth, and then they have a mix of rock and iron ones. And then these last ones, carbonaceous chondrites. These actually have some interesting things in them: amino acids, other organic materials. They give clues to the composition of Earth's core, and they kind of believe, some people believe that instead of having like the primordial soup here on Earth that somehow formulated the very early makings of life and the first organisms, they kind of think that maybe these type of comets or meteors, not comets, but meteors, brought these complex amino acids and other organic material to the Earth, and maybe seeded the Earth in a way, which kind of gets into Ridley Scott alien human existence kind of things, which are weird, but you never know. We're still trying to figure all that out, and we may never know. It happened so long ago. You can create theories, but maybe you'll never specifically figure it out. I think we saw this yesterday. This is, I think this might be at the Space Center Houston. If not, they have one very similar to it. Pretty large, almost solid metal, and all these pitting and different shapes here are from it entering into the atmosphere, getting extremely hot, and the melted bits just kind of come off in the very high wind. And so meteors usually kind of have this texture on them. Here's the Arizona crater I mentioned before. The guy built the mine and the factory to process all the metal he was going to find, and then was sorely disappointed when he figured out that the middle of the crater doesn't hold the asteroid. The asteroid breaks up and is ejected out of it. So that's not really going to happen for him. Now, we're going to get to dwarf planets, Pluto, why Pluto is not a planet, some Kuiper Belt objects, and then at the end, they don't have a slide for it, but we'll talk about the Oort cloud. So Pluto is now classified as a dwarf planet. So don't feel too bad for it, like, oh, they stole Pluto's planet status. It's still a planet. It's just got a qualifier in front of it. It's a dwarf planet. Pluto's pretty small. It's 1/5 of Earth's diameter. It's smaller than our moon, which is pretty small. It's 2,300 kilometers or 1,430 miles. It's about half of Mercury's diameter. So that means if Pluto were a planet, it would be the smallest planet. Because we don't consider it a planet anymore, Mercury is the smallest planet. Pluto exists some of the time in what we call the Kuiper Belt. The Kuiper Belt is the second asteroid belt. And so it's going to be at the very edge of the solar system, well, not really at the very edge, you'll see that in a second. At the very edge of the solar system, beyond Neptune and Uranus, it's got over 1,000 objects that we know of that are actually pretty large. A lot of them are icy instead of the rocky meteors that you'll see in the asteroid belt. Physical properties similar to those of comets, they just don't come close enough to the sun to actually get the tail and be the classic comet that we think of. But Pluto kind of exists in that area, and that is one of the issues that we'll talk about. Here's a size difference of Pluto. Here's Pluto and its moon Charon, and I'll talk about that size in a second. Pluto is smaller than Eris, which is not a planet. It's smaller than our moon, which is not a planet. And so Pluto has some issues that are keeping it from being in the planet status. One thing I'll say before we move on, its moon is really large for a moon of a planet. And if you look at them orbit, more than likely, unlike the Earth and the moon, where the Earth is squarely in the center and the moon goes around us. Pluto and Charon are so close to size that they probably orbit each other in a way. Like Pluto probably doesn't move too much, but it's definitely getting pulled around by Charon as they orbit each other. And so that could be something that we kind of use to differentiate Pluto and the rest of the planets. Why was Pluto demoted from the ranks of officially recognized planets? I'm going to say this first part maybe isn't an argument. Pluto's 1/5 of Earth's diameter and smaller than 7 other things in the solar system. Yes, that's true. We have 7 things that are bigger than Pluto that aren't planets, but those 7 things aren't planets. They don't behave like planets. We never considered calling them planets. That's not really part of the argument. This could be one, and I kind of mentioned that the moon is so large by comparison to Pluto that their orbit is probably kind of symbiotic instead of just one thing orbiting the other. Here's the real thing that I think Pluto used, and I'll talk to you about what the problems are with this in just a second. So the new category of dwarf planets fits Pluto better. These celestial bodies that orbit the sun are essentially spherical due to their own gravity, so they're big enough to be round, which is a qualification of a planet. If you don't have enough mass to have enough gravity for you to be a round shape, you're just simply not a planet. But are not large enough to sweep their orbits clear of other debris. That's the end of the PowerPoint. Let me go back. Hold on. Previous slide. End slideshow. Here is a picture. Where are we at? Internet. Picture. Boom. Here's a picture of Pluto's orbit and the Kuiper Belt. And so you can see that Pluto is most of the time within the Kuiper Belt. It does go out towards the edge. It does come in. This is an issue. Also, Pluto was discovered in 1930. Someone looked up in the last class. That was 90 years ago. Pluto's orbit around the sun is 248 years. And so since we have discovered Pluto, it hasn't even gone halfway around the sun. It's way out there. It takes a long time to go around. And so the honest truth is, our understanding of Pluto and its permanent place in the solar system is just not certain. That being said, when you go to this slide and they're like, it hasn't swept its orbit, one of the things that the Pluto supporters really pointed out was this is pretty arbitrary, and we've never ever used this kind of argument to argue for or against any of the other planets ever. It's just something that somebody came up with, and they were like, yeah, this is a thing. You got to sweep your orbit. And everybody's like, but we've never used that before. Why are we using it now? And so there's a very real chance that Pluto might be brought back into the fold at some point in time and considered a planet. I kind of agree with this, that Pluto should be classified as a dwarf planet and kind of separate from the rest. Another thing that I will point out, Pluto doesn't really have a stationary position in the solar system. If you watch that line, it comes inside the orbit of Neptune. And so if you're talking about planets and their distance from the sun, sometimes Pluto would be the furthest out. Sometimes it would be the second furthest, and Neptune would be the furthest out, depending on, what part of the century you're talking about. And so I really understand the argument of sweeping your orbit, which, to be fair to Pluto, is never, ever, ever going to happen. If you use that argument, Pluto can never be a planet because it comes out here in the Kuiper Belt. And there's no chance that Pluto's gravity kind of cleans all this mess up. It just lives in a messy area of the solar system. That being said, there's probably lots of things that could happen to Pluto over the next century or 1,000 years or 10,000 years that kind of makes it not a planet anymore, maybe not even existing anymore if it hits something big enough. And so, I understand the argument. I also understand the people that are like, no, Pluto should definitely be a planet. Right now, it's not. It's called a dwarf planet, but maybe one day it'll come back. So, real quick, they don't even have the inner planets here, but just inside of Jupiter's orbit, you have the asteroid belt. Then way out here outside of Neptune's orbit, you have the Kuiper belt. And then we have something even further out that's called the Oort cloud. And the Oort cloud is really weird. And let's see if I can get to it. Assignments, part 1, nice. I'm going to show you just this little clip. This is like a 5-minute video. We're not going to watch all of it. I'm going to fast forward over here.
But unlike the scale model, our solar system doesn't end at Pluto.
Perfect.
Don Yeoman studies near-Earth objects for NASA's Jet Propulsion Laboratory. He offers another example of a scale model of our solar system.
Okay, he doesn't explain it very well, but what he's going to show you is an example of how far away the Oort cloud is. So he's going to show you a dime, like a money dime, which is the size of the sun. Then he's going to kind of back out and show you where the Earth would be along this road, where the Earth would be, where Pluto would be, and then where the Oort cloud is around our solar system, just to kind of give you an example of how big our solar system is and how far out the Oort cloud is.
Generally thought that Pluto is the outermost member of our solar system, but that's far from the case. Just as an analogy, let's consider it a dime, the smallest American coin. If we think of this as the size of the sun,
So there's the sun.
then 2 yards away would be the orbit of the Earth.
2 yards.
Some 75 yards away, 3/4 of the length of a football field, would be the orbit of Pluto.
There's Pluto.
But the actual edge of the solar system is some 50 miles away in the Oort cloud.
50 miles away would be the Oort cloud. So Pluto is 75 yards, which is not anywhere close to even a mile. The Oort cloud is 50 miles away and probably not getting very much sunlight, maybe like very, very little sunlight. But these objects are still held by the sun's gravity. They are still a part of our solar system. They are still within the sphere of influence of the sun. And so that just kind of gives you a little idea of how far out the Oort cloud is and how kind of crazy our solar system is. I was surprised this year, like last year, the year before, the Voyager spacecraft, Voyager 1 and Voyager 2, which were sent out in the 70s, got to what they called the edge of our solar system because they got to like this bubble that the sun is kind of pushing out these solar rays to. And when they passed the edge of the bubble, their instrumentation really fell off. And they were like, this is the cliff. We know that now these spacecraft are outside of the solar system in a way. And then I read something this year that was like, oh yeah, it's going to take them like another 100, 150 years before they reach the Oort cloud. And I was like, wow, like that's a long time. And you said they were out of the solar system, but really they're not. Like if you haven't gotten to the Oort cloud yet, you're not out of the solar system. And so it's pretty interesting to think about the distances that some of these things are still orbiting around the sun. So I think that's it for today. This weekend, I will get you the homework for chapter 15 and 16. It will be on Canvas in some way where you can answer in Canvas and submit in Canvas. I also, sometime next week, early next week, I will get you like a test exam where we can find out if the what's it called? The Lockdown browser works. I might be able to test that myself, but if not, I'll send it out to y'all. And next week we'll start on chapter 16. Hopefully we'll be able to get through chapter 16 kind of quick, and we will either test on 15 and 16 at the end of next week or beginning of week number 3. So thank you for joining me online students. Goodbye and have a nice day.